Hi, I'm Paco Nathan, and I'm here with O'Reilly Media. We're at the Strata Data Conference in San Francisco. And today it's a pleasure to be joined with Dinesh Nirmal. You're Vice President of Analytics Development at IBM. And you've just given a keynote, actually.
Right. So I just gave a keynote on how enterprise AI or how the journey to AI works. A huge challenge for enterprises because it turns out that only 4% of the executives admit that they have really successfully implemented AI, which is very interesting because there's a lot of talk about AI.
Certainly.
You know, how you infuse AI, how do you bring AI into enterprise, but it's not easy. It's a huge challenge for enterprises to infuse AI into their existing infrastructure.
What are the issues that are holding them back for the ones who don't get to the 4%?
All right, a lot of challenges, right? I mean, most enterprises were not born in the last 5 years or 10 years, right? I mean, they have been around for decades. And the question is, how, they have data silos. I mean, whether it's behavioral data, there's social data, there's transactional data, there's data lakes, data warehouses, you name it. There's no shortage of data. So, but there also exist data silos. These data exist in different systems, transactional system, warehouse systems, data lakes, all those places. And different people own the data.
Right.
So, and nobody wants to move the data, right? So that's one, the data silos. Dispersion of skills is another one. I mean, you have the data engineer, you have the IT staff, you have the data scientist, you have the data steward, so you name it. So all kind of dispersion of skills in different parts of the enterprise. Then the architecture and technology that existed for decades, right? I mean, there is legacy software that probably there's nobody who knows about that software.
Right, yeah.
Right, I mean, and then the second piece is third-party software, right? I mean, a lot of banks use third-party software, for example, credit check, all those things, right? You don't have any way to infuse ML unless they change it. So, once you put all those pillars together, it becomes really tough for an enterprise to infuse ML. I'll tell you a story, Paco. I was at a major bank a few months ago, and I was taking them through the whole AI journey. And the CDO and CTO said, Dinesh, we got it. We built the model in 6 weeks. It has been 11 months. We still haven't deployed it. That is the truth about enterprise AI, is that building model is just one aspect of it. Getting the trusted data to data scientists, being able to deploy that model becomes a huge challenge. So that's in a short way, that's the answer, is that's the challenge that we face with enterprises.
I find that in some ways it's almost inverted from what some of the software engineering expectations are. Right. Building the initial model can almost be a homework exercise for somebody just starting, but all that last mile of what really matters in business with the customers, that's the difficult part.
Right, and not only that, once you deploy the model, there's SLAs you have to meet, right? I mean, you want the model to score in less than 8 milliseconds. If it's a credit card transaction, I mean, nobody's going to wait around to say it's a fraudulent or not. So you need to meet that certain kind of SLAs and milestones. So it's not easy. There's a transaction that's running under that SLA. All of a sudden, you did an in-transaction processing or infused ML into that transaction. How do you make sure you meet that SLA? So building the model, Paco, is one piece of it, but getting the clean, trusted data to data scientists is another piece of it. And then the other piece is obviously how do you deploy it? And that's where I would say 99% of enterprise have challenges that, how do we do it? How do you do to an existing infrastructure that's working so well and all of a sudden without breaking it, infuse machine learning or AI into it?
Incredible. You've said that data happens in real time, but the decisions are being made on typically what you might call stale data.
Right.
Can you describe more about what you mean about stale data? How is this differentiated? And what can people do about it?
Right. So actually, I think Forrester made that quote that all data originates in real time, which is true. I mean, regardless of it, data originates in real time. But the decisions are made on stale data, most decisions. Now we want to change that. How do you bring the real-time decisions into the real-time data? So if you look at IoT or sensor data, how can you move the processing to the edge itself? Because those are the kind of things that will help you to make those decisions on real time. Because right now what happens is the sensor data is downloaded somewhere, processed, ran a model on it, and then made a decision. That's too late. I mean, it's like running fraud detection on a data that you moved into your data lake.
No.
I mean, it doesn't make sense. You got to run fraud detection right on your transactional data. You want to run, analytics or augmented analytics right on the edge itself as the data is coming in, or build a gateway that can process that amount of data. So that's what I mean. Like, a lot of times the data is generated in real time, but most decisions end up happening on stale data, and that's the push from enterprises to move to a real-time decision making on real-time data. We are nowhere close to that, but once we get there, I think things would be a lot easier. I'll give you an example why I believe AI is not at that sophisticated level. So let's say I want to go on a vacation. I search, vacation in Russia. I found a deal, I took the vacation. Even weeks after vacation, I still see banners popping up on my browser saying vacation to Russia, vacation, cheap prices, or a product you buy, right?
Yeah.
Weeks after that, it's not happening real time. If the enterprises knew that you already took the vacation, that they could bring all the points together, all the data silos together to make that connection that Paco already took the vacation.
Yeah.
He liked Russia. What else can we offer in relation or recommend using a recommendation engine in relation to the vacation he took? They are not anywhere there, And even if you look at some of the recommendation engines, I mean, I don't want to call out any vendor, but I see recommendations coming. I can tell there is not much AI behind it. It's just because I liked, Calvin Klein. Don't send me everything Calvin Klein. I just liked a particular brand of Calvin Klein. Don't send everything, including underwear, for Calvin Klein. I'm not interested. Right. So I don't think we are there from an AI sophistication and intelligence perspective. We are in the process, but the real time, like I said, the example I gave you is very true, because fraud is true. I mean, the same thing with vacation. I mean, chatbots. How many chatbots do we know that can go 2 levels deeper, without falling apart? So, without, so that's what I mean by real-time decision making is very critical on real-time data.
There's so much upside, though, and also the challenges there. I mean, physics really prevent us from doing a lot of real-time if you have to have this long haul upload.
Right.
But moving out to the edge makes so much sense.
Right. So how do you get the processing power onto the edge, right? That's also the key, because today, if I take a small example of like a thermostat, I mean, it is constantly sniffing the data.
Right.
But it can also make the decision right there to say, if you set it to 68 or you set it to cool, it can lower or higher the temperature as need be. But that's a very small example. But you want to move that into, let's say, a plane to say, okay, this sensor on this particular device is showing wear and tear. It's time for me to order a new part using the backend or ERP system, send a processing order, so that if we can get that whole supply chain automated, then the real-time decisions make it much more there. But we are nowhere close to there. The sensor can send data, it goes somewhere, they process the data, then they make someone else makes a decision. So the decision is not made real-time, but like you said, if we can do that, I think that would be, that would be true AI, true real-time.
Huge upside for business.
Huge upside. I mean, think about it. If you are an airline customer and the airline can make decisions on real time to make you happy, know your likes and dislikes, and give you the recommendations that you need on real time, I think that's world changing.
Forrester recently put IBM Cloud Private for Data into the top tier of what they're calling the Enterprise Insight Platform.
Right.
What distinguishes the IBM approach?
Right. So what we have done is that we took Kubernetes, the open source platform layer, and we built an end-to-end data layer on top of it. So whether you're ingesting the data, or you're connecting or collecting the data, you're governing the data or managing the data, or whether you're analyzing the data or you're infusing the data, meaning you want to do bias detection, you want to do explainability, you want to see how the model is drifting and when to retrain the model or have real-time feedback loop. And being able to connect to the enterprise GitHub to say, the whole life cycle of the model. So we built this end-to-end data platform that enables the customers to go all the way from ingest to visualize without ever dropping the data, which is a very critical piece for enterprises. So today, the challenge that enterprises face is that they will have to take 10 different, 20 different, 30 different products from several different vendors, put it all together, integrate it, and then hope it works. Having an integrated end-to-end stitched together data platform on top of something like Kubernetes makes perfect sense for an enterprise that's building a platform or a data platform. Kubernetes brings a lot of benefits, like the enterprise benefits, like scalability, availability, reliability, security, and having a stitched together end-to-end platform, data platform, made perfect sense. And that's why Forrester put us at the top, because I don't think there's anything like that exists out there today, especially the fact that we had decades of knowledge of, whether it's ETL or cleaning or transforming the data, ingesting the data, connecting to the data. How do you virtualize the data? So we brought all that knowledge into a single platform called IBM Cloud Private for Data.
Fantastic. Amazing impact as far as operations, as far as risk and management, but cost savings I can imagine as well.
I mean, huge, because now all of a sudden you don't have the IT staff trying to put together 10 different products and going after 10 different vendors for 10 different problems. You have a single throat to choke. You have your end-to-end technical capability on a data platform is taken care of. So all those things, it brings in efficiency, effectiveness, cost reduction, performance, all those things. So it has been a great story so far. I mean, every customer that we have talked to, it has been really well resonated with.
Oh, fantastic. I'd like to ask you some questions about open source, kind of bring that into the mix.
Sure.
Your whole organization at IBM is very much focused in the news on open source, very much embracing this. And why is that? What does this do for IBM?
So we have been in the open source for a very long time. I mean, if you look at the Linux Foundation, we were one of the early folks who invested and helped create it. When Microsoft was pushing Windows, I mean, we wanted an alternative with Linux open source. Even if you look at Eclipse, we were pioneering that. You look at Spark, I mean, we were, a huge contributor. You look at Hadoop, I mean, we were a huge contributor into Hadoop. You look at Kubernetes, I mean, we created the OpenKube, and we made a huge investment, as you know, recently in Kubernetes. So, I mean, the whole open source and OpenShift and Red Hat. So it's in our DNA. A lot of people don't realize it, but we have been in open source long before open source become so-called, maybe sexy might be the wrong word, but so cool. So we have been there, and we continue to invest it. And if you look at our IBM Cloud Private for Data, it's built on open source with the enterprise proprietary technology on top of it. What a lot of people don't understand is that open source, unless it's combined with a vendor who can really help the enterprise, it becomes a tricky situation. Because what if it goes away, 3 years down the road? And I can give you plenty of examples on small open source project that has come in, stayed for 2-3 years and disappeared. So you don't want to be in that. So that's where a large vendor like IBM plays a huge role to come in, adopt the open source, contribute into it, create an ecosystem around it, being able to bring it back to the enterprise with security, scalability, availability, reliability, all those enterprise features, then it becomes attractive to the enterprise. But rarely can an enterprise go and consume it, given the legal, given the security, all those challenges that are
all those risks.
All those risks. So they're very careful, but having someone like IBM, they are much more comfortable because there's the backing of IBM, who is, either a committer or a contributor to the open source, have created an ecosystem around it, have put the right level of security in there, have gone through the right level of code scans through it, so all those things. So it makes a huge difference, and our customers are embracing it, and that's why I think IBM Cloud Private for Data is doing so well, is because we built it on open source, but we also brought our proprietary and core technology on top of it.
Well, we see it in the conferences here. I mean, just as one point of feedback, reviewing the proposals, I learn about new open source initiatives, different projects that are built on others, because of IBM committers who are proposing. I learn about this breadth of work coming out of IBM in open source.
Yeah, we take it very seriously and we contribute heavily. I mean, you look at Spark SQL, there's a tremendous amount of technology that went from us. So yeah, I mean, we do want to continue that.
Another question, obviously data and AI for enterprise. We've been talking about these, but they're very fast-moving targets. They're evolving rapidly. What are the big trends that you see, and how are you getting ahead of that?
So I'll name a couple. I mean, one is RegTech, meaning the regulation AI in regulatory technology. It's very tricky because one, the regulations keep changing, and other than the lawyers and the lawmakers who created it, nobody can really make too much sense of it. But if there is a way to read those thousands of pages of document, being able to extract the business terms from there, kind of relate that to your technical metadata to say, okay, here is what you have, here's the technical metadata that you have, here's the business that's relevant to it. That kind of extraction and being able to relate to it, that AI, RegTech AI, is going to be hot because that will need, so we have it in ICP for data. We call it Amelia. But there's so many different regulations exist today, and each of them requires some level of sophistication and tuning by itself. So we are continuously developing it. So I would say one area is RegTech. The other one I think is digital twins, which is gaining a lot of momentum and popularity, where you have a part of a car, but an exact digital replica exists. And any time that particular part changes in the car, the digital twin also changes. I see more and more, AI for IT is another area that I see more and more, because how do you manage your data center? How do you do compliance? How do you do, anomaly detection? How do you predict something before it happens? So I think, there are a lot of areas in AI that is really taking off. But these are a couple of areas that I think has a huge scope in the future, especially RegTech, AI for IT, and the digital twin, especially around data.
And these are not just technology issues. These are rampant social issues.
Oh, yeah.
We're talking about the infrastructure that we rely on in terms of the digital twins, talking about energy and transportation. We're talking about security and privacy and all of these issues with data as far as the compliance.
Right, and we are going through a phase where, like you said, it's so critical to maintain customers' privacy and security. I mean, you see even in the Valley, some of the companies going through the challenges. And we take it very seriously in IBM, and obviously, our customers' security and trust is number one for us. So every product that goes out, there's some level of certification that we have to do to get there. But it's so critical, so important. And as AI comes along, how do you make sure, like facial recognition, how do you make sure that you didn't recognize somebody else's face and put it out there, right? But there's a lot of new technologies coming that's kind of encroaching into the security and privacy space, which is worrisome, but especially in the social media side of things.
Fantastic. Wonderful talking with you, Dinesh.
Well, thank you so much.
Thank you.